Okay, Trig, this is part C. This is the very last day of, I guess, Trig class. So starting with 28, we're going to go to the end. Some of these problems take a little bit of time, so I apologize in advance for, hopefully this video is not too terribly long, but um, the first couple ones aren't too bad. 28, given cosine is 2/3, and then this part tells me where my angle theta lives, between 0 and 90 degrees. Okay, between 0 and 90 degrees is going to be in that first quadrant. So I have angle theta living here, and it says the cosine is adjacent over hypotenuse. Okay, so the adjacent side is going to be 2, the hypotenuse side is going to be 3. Okay, I don't have this other side over here, and I need to do that before I can find out what cotangent is. So I need to do the Pythagorean theorem because that's not a perfect right triangle. So we'll call this guy b. So 2 squared plus b squared is going to be 3 squared. 3 squared is 9. 2 squared is 4 plus b squared. If I subtract the 4 to the other side, b is going to be, b squared is going to be 5, so b will be the square root of 5. That's what he will look like. Okay, that was kind of fast, sorry. So b will be the square root of 5, and then I need to find cotangent. Okay, cotangent is the opposite of tangent, and tangent is opposite over adjacent, so cotangent would be adjacent over opposite. Okay, so the adjacent side is going to be 2, the opposite side is the square root of 5. So what I will do is cotangent of theta is 2 over the square root of 5, but I have to rationalize and find the square root of 5, or multiply by the square root of 5. So this guy will be 2 square roots of 5 over 5, and that's what cotangent will look like. Okay, so a little bit of work to that, but not too terribly hard. Okay, simplify, 29. We've got a lot of weird trig functions going on here, and if I ever don't know where to start, I always switch these back to sines and cosines. So cosecant, a way of writing cosecant, this guy is 1 over sine, okay, on the top. Cotangent is, if I look at my unit circle here, cotangent is cosine over sine. Okay, so I'm switching everything to sines and cosines. So this is cosine over sine. And then what I'm going to do is I'm just going to keep flip this guy to the top. So I'm going to multiply it by sine over cosine, because that's what he is flipped. Okay, the signs are going to cross out, and all I have left with is 1 over cosine, which is actually, what is that, secant? Secant of theta. So that's what he will simplify to. Okay, so switch everything to sines and cosines if you cannot think of what to do. Okay, all right, verify that those two things are equal to each other. Okay, so normally we start with an ugly side and we convert it to a non-ugly side. But what I think let's do here, let's put this guy over 1, and then I'm going to cross multiply. So I'm going to multiply these guys together, and I'm going to multiply the 1's together. Okay, so the 1's multiplied together come out really nicely, and that is just 1. So 1 times 1 is 1. Okay, now what I want to do is I want to do cosecant theta minus cotangent theta times cosecant theta plus cotangent theta. Okay, and one of those is plus and one of those is minus. This is like the reverse difference of squares. Okay, so what we have going on here, if we multiply these through, okay, cosecant times cosecant is cosecant squared. This will be cosecant squared theta. Okay, cosecant times cotangent is plus cosecant theta cotangent theta. Okay, that's what he will look like. Now if I start with this guy and multiply him through, this will be minus cosecant theta cotangent theta, and then negative cotangent times positive cotangent is going to be negative cotangent squared theta. So what I notice here is that this guy and this guy cross each other off, and so I just have 1 equals cosecant squared theta minus cotangent squared theta. Okay, now I have a Pythagorean identity that says 1 plus cotangent squared theta equals cosecant squared theta. So basically what I can do is I can add this cotangent to the other side, and that will become 1 plus cotangent squared theta equals cosecant squared theta, which is exactly what this trig function says here. Okay, I'm going to scoot it over. 1 plus cotangent squared theta equals cosecant squared theta. So we can go ahead and stop because those two things are the same as each other. Okay. All right. 31. Use a sum or difference identity to find pi over tangent of pi over 12. Okay. So pi over 12, I don't know how many degrees that is. Let's go ahead and do times 180 over pi so that we can get a better idea of how many degrees that is. So 180 divided by 12. Let's just do it. 180 divided by 12 is 15. So we're doing 15 degrees. Okay, and we want to do a sum or difference to get 15 degrees. So I need two angles on my unit circle already that when I add or subtract them end up being 15 degrees. Okay, so what I can do is I can say that tangent of 15 degrees is equal to, let's write it as tangent of 45 minus 30. Okay, because 45 minus 30 degrees is 15, and then but I do have a 45 and a 30 on my unit circle. Okay, so sum and difference right here. Okay, if I look at tangent, we're doing a difference one right here. So we're doing subtraction here, which means I have to do subtract and then add. Okay, that's the bottom and the bottom and the bottom. Okay, so I'm going to write this out. My formula is going to be tangent of u minus tangent of v over 1 plus tangent u tangent v. Okay, all right. So that's what my formula is going to say here. Okay, u is going to be 45, v is going to be 30. Okay, that's kind of the way that he will work out. Okay, so if I write this out, this will be 45, this will be 30, this will be 45, this will be 30. Okay, uv, uv. Okay, so I just look at my unit circle and I find tangent of 45 degrees. Tangent of 45 degrees is 1. So I have 1 minus tangent of 30 is square root of 3 over 3 over 1 plus tangent of 45 is 1 times tangent of 30 is square root of 3 over 3 again. Okay, so I have 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3 is basically what I have here. Okay, all right, last thing that I'm going to do, I'm going to find a common denominator. So this really is 3 over 3, and this guy is 3 over 3 also. So this top part is 3 minus the square root of 3 all over 3. The bottom is 3 plus the square root of 3 all over 3. That's what he will look like. If I'm going too fast, pause. You can go ahead and do that. And then I can keep flip him to the top. So he will be 3 over 3 plus the square root of 3 when I flip him to the top, and then these 3's will cancel. So my final answer is 3 minus the square root of 3 all over 3 plus the square root of 3. Okay, and that's what he will look like. Okay, all right, I'm going to skip these next two. So I don't care for sum and difference and half angle and blah blah blah. Are you awake? Yes, I am awake, but sorry, Mom. 34. Let's go to that one. Let's go ahead and solve this guy, and they're wanting us to just find between 0 and 360. Okay, the square root of 2 sine of x minus 1 equals 0. Okay, I want to solve and get x or sine of x by itself. So I'm going to add the 1 first. So I have the square root of 2 sine of x equals 1. Okay, and then I'm going to divide by the square root of 2. So I have sine of x equals 1 over the square root of 2. But if I rationalize, that will really end up being the square root of 2 over 2. That's what he will look like. Okay, now, so I'm just trying to find between 0 and 360 degrees where is sine the square root of 2 over 2. Okay, so let's go on to our unit circle. Where is sine square root of 2 over 2? Okay, unit circle, here we go. Sine is the y-coordinate, square root of 2 over 2, at pi over 4, and at 3 pi over 4, or 45 degrees and 135. So 45 degrees and 135 degrees. The reason why I wrote it in degrees instead of radians is because they said between 0 and 360. rather than between 0 and 2 pi. So we'll write them in degrees as our answers. Okay? All right, go to the back. 35. Solve the triangle. Okay, trig applications is what this one is. So we have a triangle, and I have no idea what this triangle looks like. I'm just going to write out what A, B, and C are. A is 40 degrees, B is 59 degrees. They don't tell us C, but they tell us little c is 14. So that this guy has to be 14 because he's opposite capital C. This guy's going to be lowercase a, this guy's going to be lowercase b, and they want us to solve the triangle. So that means find everything that's not already there. Okay, I'm going to list that out over here. A, B, C, lowercase a, lowercase b, lowercase c. 14, 40, 59. One thing that I can do is I can find capital C real quick. All of them have to add up to 180. So 40 and 59 is 99 degrees. So I'm going to take 180 and I'm going to subtract 99. And that is 81 degrees. So that's what capital C is. Okay, now at this point I have a pair right here. I have a grouping of the C's. And so that means that I can use the law of sines, which says like sine A over A equals sine B over B. I think maybe that was the way that they wrote it in our notes. Otherwise it's A over sine A, B over sine B. It doesn't really matter which order you put them in. You can put the sines on the top or the bottom. But I have C's, and then I can, let's just go ahead and solve the A's. Okay. So what I'll do is I'll put sine of 81 over 14, sine of C over lowercase c equals sine of 40 over A. Okay, if that's what I'm solving for. Okay, and then I can cross multiply. Okay, so A times sine of 81 equals 14 times sine of 40. Okay, now I want to be in degrees. If you're not already in degrees, make sure you're in degrees because 40 degrees and 81 are degrees. They're not in radians. So I'm going to take 14 times sine of 40, and that's going to give me 8.999. If I divide by sine of 81, that will give me what A is. Okay, so I'm going to take that guy divided by sine of 81. And that is, A is 9.1. We'll just round to one decimal place. 9.1 is what he is. Okay, and then B, we can do exactly the same thing. I'm going to even use the same proportion here. So I can still use this part, sine of 81 over 14, because I can still use my C's. But instead of this being sine of 40, I'm going to switch that to be sine of 59 over B instead. Okay. So doing the same thing again, just like that. All right. Now, some people would say, oh, just use the Pythagorean theorem with A, B, and C. I cannot do that because this is not a right triangle. So get that out of your head. Okay. I'm going to do my cross multiply. So sine of 81 times B is going to be B times sine of 81. And that's equal to 14 times sine of 59. Okay. And then I'm going to divide by sine of 81. So divide sine of 81, divide sine of 81. Okay, so B is equal to that stuff, whatever that comes out to be. 14 sine 59. I'm going to hit enter, divided by sine of 81. So B is 12.1. Okay, and I have solved the triangle because I have found everything that is not already there. Okay, all right, same thing for the next one. Solve this triangle, except the only thing they give me is the three sides. Shoot. This is capital A, capital B, capital C. I have lowercase a is 32, lowercase b is 38, lowercase c is 46. Okay, that's what he will look like. All right, now I don't have any of the angles. I don't have any of their angles. I'm going to write them over here. A, B, C, and I have lowercase a, lowercase b, lowercase c. Okay, so when this happens, I am going to have to use the law of cosines. Okay, law of cosines is A squared equals b squared plus c squared minus 2bc cosine of a. Okay, so what we can do is if we're trying to solve, let's go ahead and say we're trying to solve for capital A. I would have to put lowercase a in this spot. Okay, so I'm going to put 32 here equals 38 squared here plus 46 squared minus 2 times b times c, and then cosine of a. All right, lots of stuff going on here. All right, let's solve some of this stuff out. Okay, 32 squared is 1024. And then I'm going to go ahead and take 38 squared plus 46 squared. Let's do that. 3560, okay, is what these two together are, minus 2 times 38 times 46 is 3496 cosine of A. Okay, now the tricky part is, and I told you this before, do not subtract these two because the 3496 is attached to the cosine. Okay, so that's illegal. We cannot put those two together. Okay, but what I can do is I can subtract the 3560 to the other side. Okay, so 1024 minus the 3560, and that ends up being negative 2536 equals negative 3496 cosine of A. All right, now at this point, I'm going to divide by negative 3496. Okay, divide by negative 3496, and that is 0.7254. Oh my gosh, is cosine of A. Then to get cosine, or to get the A by itself, I have to take inverse cosine of that. Okay, let's get over here. So I'm going to do second cosine of that answer. Oh my gosh, finally, A is 43.5 degrees. Holy cow. Okay, so I have that up over here. A is 43.5 degrees. Okay, then, after I've done all that work, now I have a pair of points here, okay? And I can use the law of sines, just like we did up here, to, let's say we're finding B next, okay? So I'm going to do sine of 43.5 over 32 equals sine of B over 38, okay? And then I cross multiply. So I've got, I'll do 32 times sine of B equals this guy. And let's just multiply those together. So 38 sine of 43.5. And I get 26.16, something like that. Okay, divide the 32 to the other side. And that's sine of B. Divide 32. Okay, is that 0.817? But the last thing that I have to do is inverse sine of that number. Okay, and B finally is 54.8 degrees. And now the easy part, find C. Add these two together, subtract from 180, 43.5 plus 54.8, and 180 minus that answer is 81.7 degrees. Okay. Now it's also a good idea to kind of make sure that the largest angle is opposite the largest side. So 81.7 is the largest angle, 46 is the largest side. The smallest angle is 43.5, opposite the smallest angle, or smallest side, excuse me. So that's consistent with what it should be. Okay, just a couple left here. Now we're getting down into the vector stuff that we've done before. So given this guy, they want us to write the component form. Okay, component form was this, like with the triangular brackets, and it basically takes both of these points and it gives like one coordinate for those points. Okay, so these coordinates here, this x and this y is just going to basically say from, if I start at 2 and I go to -3, how many units have I gone in the x direction? So if I'm starting at positive 2 and I go over to negative 3, I've gone negative 5, or I've gone 5 units in the x direction. If you have to do that using, like without using your head, if you have to do a formula, you can do negative 3 minus 2. It's x2 minus x1, okay? Same way, if I'm starting with negative 1 and I'm going to positive 4, that's going to be a positive 5, okay? So that's what he will look like. And then, so what I'm doing, I guess I can draw this out. I'm starting at 2, negative 1 here, and I'm going to negative 3, positive 4. So this is what my vector looks like, something like that, okay? And I want to know the magnitude of that. So I've gone negative 5 and positive 5, okay? So if I'm trying to find the magnitude, I'm basically trying to put this as a right triangle and find the length of that, which is going to end up being the distance formula between these two, or since I know that the distance between 2 and negative 3 is negative 5 and the distance between negative 1 and 4 is 5, what I can do is just the square root of negative 5 squared plus 5 squared. It's kind of like doing the Pythagorean theorem with this guy, okay? So negative 5 squared is 25 plus another 25. This guy will be the square root of 50, okay? Square root of 50 will break down into 25 and 2. And if I take the square root of both of those, the square root of 25 is 5. The square root of 2 is just the square root of 2. So 5 square roots of 2 will be his magnitude, okay? All right, 38. Find an ordered pair to represent negative 1/2 u minus v. Okay, so I'm going to write out negative 1/2 u. Well, not negative 1/2 u, 1/2 u. 1/2 u minus v. 3, negative 2. This is what the whole thing should look like at the very end. Okay. This guy, if I multiply the 1/2 through, this will be negative 1/2, comma, and half of 4 is 2. And then I'm going to subtract 3, negative 2. That's what he's going to look like. Okay. Negative 1/2 minus 3 is going to be negative 3 and 1/2. You can write it as negative 3.5 if you want to. And 2 minus a negative 2 is going to be 2 plus 2, which is 4. So that's what his component form will look like. Okay, 2 left. We're almost there. Almost there, guys. 39. Find the magnitude and direction of the resultant vector. So what we have right here is some sort of object or something that a force is being pulled this direction and a force is being pulled this direction. Okay, and we need to figure out where it's going to go. It's probably going to go straight up here. That way, since both of these vectors are being pulled at the same force, it's going to go up here in this direction. Okay, so let's see how this works. Let's start with this first guy right here. What I want to do is this triangular piece right here has a 60-degree angle, and this guy right here is 115. Okay, so what I need to do is I need to find the component form of that first guy. Okay, and what will happen, or what I'm trying to do is I'm trying to figure out his component form is basically going to be the x direction and the y direction that are involved from getting him here to here. Okay, so the x direction is going to be, this is my x and this is my y. If I'm trying to solve for x, okay, I would do cosine because I have the adjacent side and the hypotenuse side. Okay, so the x direction, you might have remembered from like our notes and stuff that x is going to be cosine of the magnitude, or no, excuse me, cosine of the, let me write this out. X equals magnitude times cosine of the angle, I guess. We'll do it that way. Magnitude times cosine of the angle. The y is equal to the magnitude times sine of the angle. Okay. So if I have this going on here, that's the reason for that. I'm trying to find the x direction, that's cosine. I'm trying to find the y direction, that's sine, because it's opposite over a hypotenuse and adjacent over a hypotenuse. Okay, so if we do this to each one of them, I have 115. Let me zoom out here. 115 cosine of 60, and I have 115 sine of 60. Okay, so 115 cosine 60 is 57.5. So that's how far he is in the x direction. That would be this way right here. Okay, and then if I do 115, I'm just going to go back, and I'm going to change that to sine. 115 sine of 60, that's 99.6. Okay, now I'm going to do the same thing for this vector right here, except that's 120 degrees. Okay, so I do 115 cosine of 120 and 115 sine of 120. Okay, 115 cosine 120. That is a negative 57.5, and we want to write that as a negative 57.5. Okay, and then we have 115 sine of 120, and that is negative 99.6. Oh man, we add those two together, it's going to cancel out, and it's going to be 0, 0. Poop. What in the heck is going on with that? Because it's going to go straight up into the air. So find the magnitude and direction. It's going 0 in, well, 0 in the x direction, 0 in the y direction. It should be going something in the, oh, no. This is positive. Positive 99.6. There we go. That's why. It's this one is not 0. 99.6. When I did sine of 120 times 115, it was positive 99.6. So both of them are positive, which means I have 99.6 plus 99.6. There we go. So this guy is 199.2. So what's happening here is it's not moving any in the x direction, but it's going straight up in the air, 199.2. Okay, so that's going to give me my magnitude. It's going to go 199.2 kilometers per hour. This is my magnitude, and the direction is going to be straight up in the air. A lot of times we'll call that a 90-degree direction. Okay, so find the magnitude, find the direction. Because there's x coordinates crossed out, he's going to go straight up. So a 90-degree direction, 199.2 magnitude. So kilometers per hour, straight up at a force of 199.2. Okay, I hope that made a little bit of sense. I don't know. We'll see. Number 40. Let's try to kind of clear up some things with this one. Find the initial horizontal and vertical velocity of a soccer ball that is kicked with an initial velocity of 7.5 meters per second at an angle of 20 degrees with the horizontal. Okay, so I have this going on here. Here's the direction that my soccer ball is traveling. It's making a 20-degree angle with the horizontal at a rate of 7.5 meters per second. They want the initial horizontal velocity. So basically on the ground, how fast does it look like it's going? And straight up, how fast does it look like it's going? Okay, because if you're standing like underneath of an airplane as it's traveling upward, it doesn't look like it's traveling very fast horizontally and traveling very fast vertically, but it's actually going like 300 miles per hour going this direction. So they need us to figure out what this guy is and what this guy is. Okay, and that's exactly kind of what we did up here by doing the x direction is the magnitude times the cosine of the angle, and y is the magnitude times sine of the angle. Okay, because basically this is the adjacent side over hypotenuse, and this is the opposite side over the hypotenuse. So opposite over hypotenuse is sine, adjacent over hypotenuse is cosine. So to find out this guy, we're going to do 7.5 times cosine of 20, and this guy is going to be 7.5 times sine of 20, and that's going to give me my vertical and horizontal velocities. Okay, so 7.5 cosine of 20, which is, so he's only going horizontally, he only looks like he's going 7.0 meters per second. Okay, vertically, it looks like he's going, it looks like he is going 2.6 meters per second vertically. Okay, so that's how those are kind of changed. When those are combined together, I guess you could have used the Pythagorean theorem to figure out the third one if you wanted to, but those combined together will give me a 7.5 meters per second at that angle, okay? So component form, if I would write that as in component form, it would be 7.0 comma 2.6, which is kind of what we did up here, and we added those together, okay? So ending on that, we didn't do anything from chapter, what was it, chapter 11, I think we didn't do any matrices, but we just kind of finished up with those, so hopefully you kind of have that fresh in your brain. This is the end of Trig. That's it. You guys are all juniors, so I will see you again next year in whatever math class you take, so probably either stats or calc, you know, one of those two. But I wish I could see you in person. Sorry for the circumstances. There's nothing really I can do about it. Yeah, have a great summer, and I'll see you again in the fall, hopefully.